So hello students, today we see some problems on solve based on solubility product. See the first one. So the calculate the solubility means we have to calculate the solubility ES of nickel carbonate in moles per liter and grams per liter means we have to calculate the solubility. The value is information is given about solubility product. So for this type of problems at first we have to know which formula we need to use for the solubility product. So before that we must know about the type of salt. So here nickel carbonate. So it comes under Na plus 2 CO3 minus 2 means 1 mole of Na plus 2, 1 mole of carbonate ions means it is a AB type of salt. It is AB type salt. So AB type of salts, what is the KSP value? So already we know the formulas for AB type of salt solubility product equal to S into S, that is S square. Simple. In this problem we have to find S. S find out chart. S means nothing but solubility. So KSP equals S square. KSP is given. We have to find solubility product, that is becomes root KSP. So therefore, the formula, so S equal to root. What is the KSP is given? 1.4 into 10 power minus 7. So here it may be written. So write it as 14 into 10 power minus 8. Okay. So overall here, so it is known that root 14 value is 3.74, and here the 10 power minus 8 can be written as 10 power minus 4. So S means what are the units? Moles per liter. So 1 solubility, 1S equal to 1 mole per liter. S square root of moles per liter square. So with the help of S square, here we calculated solubility. Means with the help of solubility product, we calculated the solubility of this salt in terms of moles per liter. And 1 liter of aqueous solution, how many moles of salt can be dissolved? 3.74 into 10 power minus 4. So this is the first answer. So the question is also there. We have to find its solubility in terms of grams per liter. అంటే 1 లీటర్లో ఎన్ని మోల్స్ ఆఫ్ సాల్ట్ డిజాల్వ్ అయిందో ఫైండ్ అవుట్ చేసినాం. ఇప్పుడు అదే 1 లీటర్ సొల్యూషన్లో how many grams of salt is present find out చేయాలి. So very simple. In the terms of moles, మనం moles should be converted into grams. We know that 1 mole equal, what is the mass? 1 mole equals mass equal to its molar mass. So here the point we have to observe is 1 mole mass. Okay, nothing but so the perfect point we can write mass of 1 mole substance or any substance is equal to molar mass. Molar mass, nothing but gram molecular weight. Nothing but molecular weight. So therefore, same, the solubility in terms of grams, we can write 3.74 into 10 power minus 4 moles per liter. 1 mole equal to, what is the mass? Its molecular mass. So what is the mass of nickel carbonate? So nickel carbonate mass is 118.7. So we can generally we used to calculate it as a 118.5. So on this overall calculation, we will get some overall calculation will get 0.004. Sorry. 0.04 grams per liter, means these two are the answer. The solubility in terms of moles per liter, solubility in terms of grams per liter. Okay, so like this we do many problems. So take the second problem. Okay, see the next one. So find the solubility of determine the solubility. Yes, solubility of silver chloride salt, and find the molarities of individual ions and solubility in grams per liter. So actually there is a three types problems are there totally. So the determine the solubility of AgCl. So general solubility is in terms of moles per liter. So the question continuation, we have to find the molarities of the individual ions also. So means Ag plus ion concentration and Cl minus ion concentration also have to find. Molarity means nothing but in terms of moles per liter. And total solubility product moles per liter lo find out chali. Molarities of individual ions nothing but moles per liter lo find out chali. And also have to find the solubility in terms of grams per liter. Just individual ions, the calculation of individual ions which are dissolved. Adukata extra manaki last problem to compare this thing. So here the clue is given. The clue is given that's KSP. So without KSP we can't do this calculation. So it will be given in the problems. Okay, 1.8 into 10 power minus 10. So if you see the AgCl, so which type of salt? So just by seeing this we can understand Ag plus Cl minus. So which type of salt? AgCl, it is AB type salt. It is AB type salt. So AB type of salts means we know KSP is equal to S square. So and yes, just now we done it. S is equal to root KSP. So they are in 1:1 ratio. S equal root KSP means S equals root value again 1.8 into, so 10 power minus 10. So the S here root 1.8 is given as 1.34. Root 10 power minus 10 means it will 10 power minus 5 moles per liter. So it is solubility. It is This is the first answer. This is the solubility of silver chloride. The solubility of silver chloride in terms of moles per liter. So here one more important. What is the second problem in it? The second is we have to find the molarities of individual ions. We have to find the concentration of molarities means nothing but concentration, nothing but solubility. Ag plus ion, Cl minus ion separate to find out shall. So very simple. So we know that what is the KSP actually? The KSP is equal for this Ag plus concentration, Cl minus concentration. Both are in 1 mole 1 mole because AgCl decomposed to 1:1 ratio. Ag plus Cl minus means it's a solubility. What is its solubility? So here it is 1 mole. So we can write 1s. It is also 1 mole. We can write it 1 mole. Yes. Means the concentration of Ag plus ion and Cl minus ions are exactly equal because they are in 1:1 ratio. So therefore we can write directly, so the Ag plus concentration, which is also equal to nothing but Cl minus concentration, so nothing but equal to it's a solubility. Yes, that is 1.34 into 10 to the power of minus 5 moles per liter, and both are having same concentration as it is a 1:1 ratio salt. Okay, so AB type of salt chemistry, so directly we written like this. So next, what is the third problem in this? Means what is the molarities? Molarities of Ag plus is 1.34 into 10 power minus 5 moles per liter. What is the molarity of Cl minus? Is also 1.34 into 10 power minus 5 moles per liter. Okay, next. So then we have to calculate the solubility in terms of grams. So already we calculated S. Solubility of AgCl we calculate as 1.34 into 10 to the power of 5 moles per liter. So in terms of grams, how you calculate in terms of grams? So we know that 1 mole equal to moles per liter. What is the convert into mass? 1 mole mass equal its molecular weight, 1.34 into 10 power of 5. So what is the molecular weight? What is the molecular weight of AgCl? So we know that silver is 108. 108, this is 35.5. So how many are there? This is totally so there is 143. 143.5. Now it comes into in terms of grams, that is 1.92 into 10 power minus 5 grams per liter. Means how many grams of silver chloride dissolved in 1 liter means 1.9492 into 10 power minus 5 grams. Sorry, not exactly. So there is a, so after modification it becomes minus 3. Actually 143.5 into 134, here we get 192. By modification it becomes 1.92 into 10 power minus 3 grams per liter. So we will calculate the same, understand the question exactly same. I have to calculate the solubility and also individual molarities and also solubility in terms of grams per liter for further ions also, for further salts also. Okay. Next, see one more problem. So calculate the solubility. Calculate the solubility of ferric hydroxide. Calculate the solubility of ferric. Ferric means Fe is taken 3 in moles per liter, in grams per liter, and find the individual concentrations. And find individual ions molarities. Okay, the same problem. So here the KSQ of ferric hydroxide is given how much? That is 10 power minus 38. Okay, see the problem here. Same, one more important. Here, what is the FeOH taken 3? So before going to proceed the problem, we have to recognize which formula should be used for KSP? Which formula should be used for KSP means we must know about the which type of salt. So ferric hydroxide means it is a Fe plus 3 and 3OH minus means which type of salt? This is a AB3 type of salts. How it is? It is AB3 type of salt. It is AB3 type salt. So AB3 type salt, this is 1 mole of Fe plus 3, 3 moles of OH minus. So for this, how you write the x power x, y power. So for general, we have the general formula for AX BY salt. How to write the KSP of AX salt, AX BY salt, x power x, b power y, sorry, x power x, y power y. Solubility product common formula on x power x, y power y, solubility x plus y. So direct ga manam find out cheyadam kante with the help of this formula we can do any type of calculation. This is 1 each. And what is the x value? X value 1. What is the y value? 3 moles. Okay, 1:3 ratio. So x power x means 1 power 1, sorry, into 3 power 3, s power 1 plus 3. So what is the KSP value? So 1 power 1 nothing but 1, 3 cube, this is 27, 27 s power 4. So this is the formula for KSP for this formula. So for this type of salts. So as you know the KSP value, so therefore what is s power 4? S power 4 equal to KSP by 27. So that is equal how much? 10 power minus 38 by 27. So what is S? S equal to fourth root means minus 38 by 27 overall power. Fourth root means that becomes whole power 1 by 4. Whole power 1 by 4 on this overall calculation. So you should be perfect in the calculations. So generally this type of values they given in the problems as a clue. So finally on this calculation we get the S value as 1.4 into 10 power minus 10, approximately 1.39 into 10 to the power of minus 10 moles per liter. So this is the first answer, the solubility of a ferric hydroxide in terms of moles per liter. So next we have to find, what is the second question? We have to find it in terms of grams, in terms of grams per liter. In terms of grams per liter, so S equals already we know, or we can write S equals 1.39 into 10 4 minus 10 in the place of mole. Mole means something that we know, molar mass. So Fe ferric hydroxide, FeO is taken 3 molecular mass, how much? So we know that iron 56 on this calculation we will get molecular weight how much? That is 106.85. We will get the molecular weight as 106.85. This is iron is 56, oxygen 16, hydrogen 1. So on this overall calculation, here we will get the answer, that is 1.4 into 10 power minus 8. Actually here we get approximately 140. So just on simplification it becomes 1.40 10 power minus 8 grams per liter. Means the solubility of ferric hydroxide grams per liter is 1.40 10 power minus 8. So the solubility in terms of moles per liter, in terms of grams per liter, very easy. So first మనం moles per liter లో calculate, it's compulsory moles per liter లో find out చేస్తాం. సో అంటే మెయిన్గా మనం మెయిన్ కీ పాయింట్ ఏంటంటే ఈ ప్రాబ్లమ్స్లో Just we have to find which type of salt. మనకి ఇచ్చిన సాల్ట్ AB టైపా AB2 టైపా అంటే దాని నుంచి వచ్చే అయాన్స్ రేషియో మనకి ఫైండ్ అవుట్ వి మస్ట్ నో ఇట్. సో దాన్ని బేస్ చేసుకొని మనం AXBY మోడ్లో ఫార్ములా రాసేస్తాం. సో ఆ ఫార్ములాతో ఫర్దర్ క్యాలిక్యులేషన్ బికమ్స్ ఈజీ. Next, the question is the calculation of individual ions. So, calculation of individual ions, we are taking the third problem in this. So, third case, so this is ferric hydroxide. The ferric hydroxide, we know the ions. It is Fe plus 3 ion and 3 OH minus ions. This is not 30, 3 OH minus ions. 3 moles means 1 mole of ferric hydroxide releases 1 mole of Fe plus 3 moles of OH minus. So generally we know Ksp is equal to the solubility, nothing but dissolved concentration of Fe plus 3 and OH minus. So Ksp equal actually Fe plus 3 is only 1 mole, so thus we write 1s and power also 1, that is s power s. Next, what about this? This is a 3s. So generally it can be taken as a 3s whole cube as general formula. That's why total becomes 27s power 4. So based on this, the solubility of Fe plus 3 means the molarity of Fe plus 3. The molarity of Fe plus 3 is nothing but equal to S. So that is how much? 1.40 into 10 power. Sorry, moles per molarities కాబట్టి we must take in terms of moles per liter. సో డైరెక్ట్గా దీనికి ఫైండ్ అవుట్ చేయాలి. ఇక్కడ ఈ వాల్యూ డైరెక్ట్గా చేయకండి, మోల్స్ పర్ లీటర్లో ఫైండ్ అవుట్ చేయాలి. ఇట్ ఈస్ 1.39 into 10 power minus 10 capital M, నథింగ్ మోల్స్ పర్ లీటర్. సో అది మనకి OH minus concentration. OH minus concentration is how much? 3 moles. So that's why I have to take 3s. So that is a 3 into 1.39 into 10 to the power of minus 10. So here approximate the calculation value, we will get 4.17. 4.17 into 10 to the power minus 10 molarity. So individual ions find out చేయడానికి కంపల్సరీ ఇన్ టర్మ్స్ ఆఫ్ మొలారిటీస్లో ఉంటుంది. దాన్ని మనం సాల్యుబిలిటీ ఇన్ మోల్స్ పర్ లీటర్ బేస్ చేసుకొని ఫైండ్ అవుట్ చేస్తాం. ఓకే, next we do one more problem like this. So determine the solubility of mercuric chloride. This is determine the solubility of mercuric chloride in moles per liter, in grams per liter, and find molarities of individual ions. So in the question, I think they given the Ksp value of this. Ksp value of this salt is given as 5.6 into 10 power minus 23. So what is the type of salt? We know the HgCl2. HgCl2, we know that it becomes the mercuric ion. So actually I think it is mercurous, not mercuric. So Hg plus 2 and 2Cl minus. Okay. So this is which type of salt? This is AB2 type. AB2 type salt. So AB2 type salt. Therefore, what is the KSP? KSP equal to, we know that 1 power 1, 2 power 2 means it becomes 4, and s power x plus 5, 1 plus 2, that is become 4s cube. So how much KSP is given? So therefore, on the first calculation, the 4s cube equal to 5.6 into 10 power minus 23. S cube equal to the 5.6 into power minus 23. By 4 is also there. So and S equal to, you will get how much? So the 5.6, we are adding it as a 56 into 10 power minus 24, so by 4. So cubic root in total becomes 1 by 3. So S equal. So this is 14, made the 14 whole power 1 by 3 and 10 power minus 24 whole power 1 by 3. So 14 whole power 1 by 3 here. So separately it is given that 14 whole power minus 3 is given as 2.41. 2.41, this is 10 power minus 28, this is into 1 by 3, simply it becomes 10 power minus 8 moles per liter. It is moles per liter. I mean, this is the solubility in terms of moles per liter. So next we have to calculate the solubility in terms of grams per liter. So the solubility in terms of grams per liter we calculated as so the 2.41 into 10 power minus 8 mole. So 1 mole means we know it's equal to molar mass. So here HgCl2. So molecular mass Hg, that is how much? That is generally Mercury's molecular mass is taken as 200. So here I have to take the molecular weight. Mole means in terms of mass, molecular weight. So what is the molecular HgCl2? So molecular weight, but only once Hg is there, so approximately 200, so 71 becomes so 271. So here S value, total S value in terms of grams, so becomes 653. 653.11 into 10 power minus 8 grams per liter. Grams per liter. So generally మనకి one fraction so తీసుకోవడం, so general procedure, it can be written as 6.53 into 10 power minus 6 grams per liter. So this is the solubility of mercury chloride in terms of grams per liter. Next we have to calculate the individual ions concentration, nothing but individual molarities. So individual molarities, we know that HgCl2, so it is Hg plus 2 and 2Cl minus. So what is the solubility? Its solubility is yes, its solubility is 2s. So therefore the molarity of Hg plus 2 in the solution is exactly equal to yes. So 6.53 into 10 power minus 6 moles, sorry, we have to take in terms of moles per liter. So molarity, actual question of molarity undi kabatti we have to find in terms of moles per liter. So how much you got in terms of moles per liter? That is 2.41 into 10 power minus 8 moles per liter. Then whatever Cl minus concentration, solubility is 2s, means 2 into 2.41 into minus 8. So that is 4.82 into 10 power 8 molarity. Okay, so these are the one of the types of problems on solubility. So there is some other models are there.